Einstein Photoelectric equation. After the laws of photoelectric emission, which we have obtained from the experimental setup and its effects followed by the laws, we are going to understand further modification of photoelectric effects with Einstein ideas. What are the Einstein ideas here? Einstein used the Planck quantum theory, and the Planck quantum theory, the quantum nature is a word, quanta, which is called as pockets, that he has introduced here. Light travels in a form of photons, then each photon carries a bundles of energy in a form of packets of energy. So this concept he has introduced here, therefore he has modified the photoelectric effect such a way that when a photon of energy, which is E equal to h nu, falls on a metal surface with the suitable frequency, and the energy of the photon is absorbed by the electron which is there in the metallic plate, and after absorbing, what it will do? First, it's supposed to overcome. Electron needs to come out the metal plate, in the sense it should overcome from the metal plate, and as well as after this, after overcoming the work function, if the rest of the energy, if more energy is available, the energy is useful to travel in further direction with some kinetic energy, and therefore it reaches the opposite potential plate, and that is contributes for the photoelectric current. These 2 points is indicating that only. A part of energy is used to overcome the surface barrier. The surface barrier, in the sense, though your suitable frequency you are emitting on a metallic plate, all the metal plates will not be emit out the electrons that we know, right? So we should have the enough work function of that metal surface is required. So this work function, if it is overcomes, then for this overcoming, we need some extra energy. That is, a part of energy is used to overcome the surface barrier and come out of the metal surface. This part of the energy is called, whatever the energy is used to overcome is called as work function. Okay, that is pi equal to h nu naught we are writing. Nu naught, why you are, nu naught is a threshold frequency. It is a minimum optimum frequency to overcome the work function. The second one is that after that the remaining part of the energy is used in giving a velocity to the electron, and therefore the electron will move forward direction with some amount of kinetic energy. Then the electrons, whatever it is moving in the further with the some amount of kinetic energy, which is reached the opposite potential, therefore it contributes for the photoelectric current, that is of mv square. Since it is maximum kinetic energy, if it is having, so we can say of mv square maximum. So that is kinetic energy which is supposed to used to travel further direction. Let us see here a metal surface. I'm using a photon. I'm inciding a blue color light. One photoelectron is emitted. How it has emitted? The work function has used to overcome outside. Then next, the kinetic energy which is used to move in further direction. This is the way the photoelectric effect takes place. Look at here, incenting and overcoming the barrier, then further it's gaining kinetic energy. Means the energy which is we are incidenting, it must more than the threshold frequency, therefore it moves in forward direction. So according to law of conservation of energy, we know that what is the law of conservation of energy? That is h nu, the energy which is incident on the metallic surface is equal to the photon energy which is incidenting, that is phi plus half mv square maximum. Phi is indicating that work function which is overcoming, as well as some amount of the energy is used to move in a forward direction. Therefore, I can write this is in a further phi equal to, we know that h nu naught, the photon energy which is used to overcome the threshold frequency by work function. So I can write this equation, the kinetic energy, maximum kinetic energy equal to h into nu minus nu naught. This is the actual Einstein photoelectric effect equation. H into nu minus nu naught means change in the frequency into H equal to half mv square, maximum kinetic energy. This is a Einstein photoelectric equation, is a standard form. Okay, so I hope you understood how Einstein has used the photon, how it emits or imports the energy on the metallic surface. Therefore, how it is used, also we can understand. Yeah. Okay, the next verification of laws of photoelectric emission based on Einstein's photoelectric equation. We studied the laws before. Okay, that laws how it is verified with the Einstein photoelectric equation that we need to discuss. We know this is the Einstein equation. This equation, first case, if you see, if the frequency of nu is less than the nu naught, then there will be no further kinetic energy. The kinetic energy is negative form, which is actually not possible. Energy never be in the negative. Okay, so always nu must be greater than nu naught. Then only the kinetic energy is possible. Now, since one photon emits one electron, then the number of photoelectrons emitted per second is directly proportional to intensity of incident light, right? Then it is also clear that whatever the maximum kinetic energy of mv square max is directly proportional to the frequency which is supplied from the source, and whereas h and nu naught are constants here, this we can understand. This is shows that maximum kinetic energy or kinetic energy of photoelectrons is directly proportional to the frequency of the incident light. Means it depends on clearly incident light. Now, photoelectric emission is due to collision between a photon and an electron. Photon comes, imports the energy on the electron, then because of the collision between the photon and electron happens. Now, as such, there cannot be any significant time lag. As I said, we discussed in a previous loss, that is, it is an instantaneous process we said. But here, there is, there cannot be any significant time lagging between the incident of photon and emission of photoelectron. This is a process is instantaneous. It is found that delay is only 10 to the power minus 8 seconds. Okay, the time delay is takes place between the 10 to the power minus 8 seconds, approximately nanoseconds it takes place here. These are all we can consider the verification on laws of photoelectric emission on the basis of Einstein equation. Now, what are the applications of Einstein photoelectric equation? Means the revolutionary application in photoelectric effect. That's why Einstein became famous, and he got a Nobel Prize for this. First, nowadays automatic fire alarms has come. When fire has come, suddenly in foreign countries like USA and all, even if you do stick also use, then automatically the fire safety alarm will ring at the fire station. Then from the fire station, the fire engine comes. It means automatic burglar alarm. Even burglar alarms are available nowadays in ATM also, wherever the area ATM, if it is breaking or if anything happen, that area police station will get signal. And scanners in television transmission also, it is useful photoelectric effect. Reproduction of sound in a cinema, films, editing of sound and all. In this case also it is useful. And paper industry to measure the thickness of the paper industry we are using. To locate flaws or holes in the finished goods. This is helpful. And in astronomy, the other way. And to determine the opacity of solids and liquids, also it is useful. Now, automatic switching off the street lights. Nowadays, you are finding on the roads the solar lamps or solar lights. Okay, on that small square solar panel. Now, to control the temperature fans, automatic controlling system we are using. Photometry, nowadays you are enjoying so much photography, new mobiles has come, so much revolutionary has come in mobiles and in cameras also, and holograms has come. Beauty meter to measure the fair complexion of skin. Nowadays, if you see the mobiles to that, it shows your age by looking at your face in the mirror to the camera. And same like beauty meters also has come. Light meters used in a cinema industry to check the light, how much intensity of light or brightness supposed to decrease or increase. So photoelectric sorting also we are prefer to use. Photo counting depends on the number of people which are moving across the LED, and when the people are entering and leaving in shopping malls and theaters. This all happens because of photoelectric effect only. Meteorology. In meteorology also this is more helpful, this photoelectric effect. Okay. This is all about the applications of photoelectric effect. If you go in detail, you can understand much and much. So many applications are there. So that's why this is so famous. And due to conclusion of a modified equation, modified photoelectric effect due to the Einstein, it became so famous. So it became great. Apart from the relativity theory, from this. Thank you. Please subscribe my channel, everyone. Bye.